Good morning, everyone. Today we are going to start our next part of the chapter, that is light of class 10th. The next part we call as refraction or refraction also. So, as I've told you in the first video of this chapter, in the first lecture, in the beginning only, that there are two parts of light or two processes that light performs. One is refraction and the other one is reflection. Reflection we have already done. Now it's time for refraction. Refraction means, I've told you earlier also that refraction means the change in medium, right? When the light enters from one medium to another medium, that process is known as refraction, right? Okay. Next, speed of light is maximum in case of vacuum, as vacuum is least tensor, you can say. 3 into 10 raised power 8 meter per second, that's the speed of light. We can denote the speed of light by c. Now, cause of refraction. What will be the cause of refraction? Change in speed of light can be the cause of refraction. Why that change will be there? Because when a light moves from rarer to denser medium, that is what you mean by rarer. Rarer means least denser or less denser, and denser means you always understand where it is more populated or where the more number of particles are present. For example, let's take an example of air. Air is less denser, that why we call as rarer, and glass is more denser, that's why we can call as denser. So air is rarer medium and glass is denser medium, because air has large particle spaces in between them and glass is quite tightly packed. So the density is basically uh, in particular area, when the number of particles are present in more quantity, that is more denser, right? Okay. Now, some examples of refraction are: the bottom of swimming pool appears higher. As you have gone in some swimming pool, you might have observed that the bottom surface little bit rised up when you try to look inside the swimming pool. Or you can perform the activity at home also. Take a glass of made up of glass only, right? So what you will observe, what you have to do in that case, fill some portion with water, or you can say half of the glass should be filled with water, and insert a pencil in it. What will you observe is, when you try to look inside the glass at the tip of the pencil, it appears to be raised up, right? So why it appears to be raised up? Because of refraction of light. See this, it appears to be a little bit raised up. The actual position of the pencil is here, but when you try to see it inside, then it appears to be raised up, right? So it's a apparent position, we can call it. Understood this part? Okay. Next is, lemons placed in a glass tumbler appears bigger. Letters of book appear to be raised when seen through a glass slab. You can try these activities. These are quite simple, and the things can be available at your home also. Refraction through a glass slab and refractive index. What happens in this case is, as you can see, we have done two laws of reflection. Now it's time to do two laws of refraction or rarefaction also, right? Okay. Now in this case, what happens is, this is the normal ray, this is the incident ray, and this is the refracted ray. In that case, in case of reflection, it's going in the same medium, but in this, the refracted ray is going in the other medium. Why? Because this is refracted ray, that one was reflected ray. In case of refraction, as I've already told you, that the medium is getting changed over here, right? So this is the incident ray and this is the refracted ray. So when the incident ray strikes a surface and tries to enter in the denser medium, it bends where? Towards the normal or away from the normal? You can see over here I have written something. Rate bends towards the normal if this is denser, right? So it bends towards the normal or away from the normal. If n2 is greater than n1, then it bends towards the normal. If n2 is less than n1, then it bends away from the normal. Right? So this is basically a diagram that shows you the principle of refraction. Let's try to understand it more simple way. This is bouncing back of light when it strikes on a polished surface like mirror. Now this is a glass lab. This activity might be you have performed in class 8th or 9th. Bouncing back of light when it strikes a polished surface like mirror. Take a glass slab. What you have to do in this case, uh, put a pin over here and one pin over here, two pins over here, and try to look from this surface, right? This side. So what will you observe? You will observe that the pin which is kept over here, it seems to be visible from here only, right? That means the light which is refracted will follow this path, right? When it will follow this path, the rays will come out from here, and you will mark this ray as emergent ray because the refracted ray is the inner one, right? As the light enters from rarer to denser medium, so it bends towards the normal, right? You can see this. This light is bending towards the normal. If it bend away from the normal, then it should go there, right? So denser medium, in case of denser medium, light bends towards the normal. So in this case, the light is bending like this, and the emergent ray is coming out to be like this. Now this angle of incidence, which is formed with the normal, is equal to the angle of refraction. But one more thing you have to observe: this angle of incidence is equal to the angle of refraction. That is possible, but these two angles, angle of emergent and angle of incident ray, should be equal, right? Okay. Now this process basically is known as lateral displacement also. This line, as you can able to see, that is known as lateral displacement line. Now the extended of bending of ray of light at the opposite parallel faces of rectangular glass slab is equal and opposite. And so the ray merges parallel to the incident ray that I have already explained to you with the help of diagram. Now what is lateral displacement? And on which things it depends upon. Lateral displacement is basically it depends upon refractive index of the glass slab and thickness of the glass slab. Now, what is lateral displacement? That light has to go over there, but it has been displaced from its path, and how much it has been displaced, that will directly depends upon the refractive index of the particular glass slab or the thing that we are taking or the substance we are taking instead of glass. Also it can be changed, and the thickness of that particular substance or the medium, right? Like in this case we have taken glass slab, so thickness of the glass slab and refractive index of the glass slab, these two factors play a very crucial role over here. Now, that's the important one, laws of refraction. So, what does that mean? The incident ray, the refracted ray, and the normal to the interference of two transparent medium at the point of incidence all lie in the same plane. That's the same as law of reflection, that the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane, right? Now, the second one is different. The ratio of sine of angle of incident to the sine of angle of refraction is constant. That means the sine of angle of incident means sine of I upon sine of R is equal to a constant. When you will get the values of this, that will be a constant. Don't worry about sine I and sine R because this is a mathematical term. Sine you are going to use in chapter 8 of mathematics in your NCRT books, that is known as trigonometry, right? Don't worry about this. This plays an important role. This formula we are going to use in case of numerical. I will show you a table. You have to learn that table in order to solve the formulas related to this. Don't worry, I will teach you about some concepts of maths also. So in this, sin I by sin r is equal to constant. That's why we have called the ratio of sine of angle of incidence to the sine of angle of reflection is a constant, right? Sine of angle of refraction is a constant for a light of given color and for a given pair of media. Now, the other thing is refractive index and absolute refractive index. Refractive index means the ratio of speed of light in a given pair of media. That means what will be the ratio of the speed of light when a light travels from a rarer to denser, denser to rarer medium. So n to 1, when we are going to write it like this, n to 1, that means the refractive index of second medium with respect to first medium, and we are going to write n12, that means refractive index of second medium with respect to first medium. They both are not same. By mistake I have written here, right? So that means refractive index of first with respect to second. Don't worry, I will change it. And the ratio of the size of light in a given pair of media, where n is equal to velocity of light in medium 1 and velocity of light in medium 2. So you have to understand this first of all. N is velocity of light in medium 1 upon velocity of light in medium 2. That means if we are writing like this 2 to 1, that means from medium 2 to medium 1, right? And when we write 1 to 2, that means from medium 1 to medium 2, right? Okay. Now, absolute refractive index. Refractive index of the medium with respect to vacuum or air, right? So, absolute refractive index means we have to take the refractive index only, but with respect to vacuum or air. So, n is equal to C upon V into C. So that means 3 into 10 raised power 8 meter per second is the value of C. So the formula is only C upon V, right? So here the value of C is 3 into 10 raised power 8 meter per second. Now refractive index of one medium is reciprocal of other refractive index in a given pair. For example, how we are going to write in this case is if we are going to find out the refractive index of 1 and 1 2, then we have to apply this formula 1 upon n 2 1. If the refractive index of medium 1 with respect to air is given as 1 n air, so we are going to write like this. जब रिफ्रैक्टिव इंडेक्स ऑफ मीडियम 1 हमें लिखना है, दैट इज विद रिस्पेक्ट टू एयर हमने लिखना है, तो हम ऐसे लिखेंगे, ये ऊपर आएगा, वन नीचे आएगा। और जब रिफ्रैक्टिव इंडेक्स और मीडियम 2 हमें निकालना है, तो उसको सिंबॉलिक रिप्रेजेंटेशन में लिखना है, तो 2 नीचे और एयर ऊपर आएगा, राइट? आई होप यू हैव अंडरस्टूड दिस कंसेप्ट। That's a quite complicated one. Don't worry, when we are going to do it in numerical part, we are going to expand it more, right? So by the applying the applications in case of numericals, we are getting more clarification related to this, right? Till now, you have done only the definitions of this. Okay, the refractive index of medium 1 with respect to medium 2. This is the formula 1 n air upon 1 n air. So it will be 1 only in this case. So refractive index of diamond is the highest rate, that is 2.42. What do you mean by the refractive index now? Now it will be easy to understand. If the refractive index of diamond or any substance we say is 2.42, what do you mean by this statement? It means speed of light is 2.42 times 1 upon 2.42 times less in diamond than in vacuum. Or we can say the speed of light in vacuum is 2.42 times greater than in diamond. That will be more easy, because diamond is a denser medium, right? So try to understand this. Diamond is a denser medium, and when you enter a denser medium, or when anything enter a denser medium, what happens in that case is we find different ways, or our speed gets slower in that case, right? Because that's a denser medium, and in order to pass through a denser medium, we have to decrease our speed. Like you are entering a road, right? You are going through a road which is having a dense traffic. What will happen in that case? Your speed will decrease automatically. If the road is empty, what will happen? That means it's a rarer medium, then you can speed up your vehicle, right? So optically denser medium means out of the two medium, the medium with higher value of refractive index, that's a denser medium, and with lower value of refractive index, that's a rare medium. तो जिसका refractive index कम होगा वो rarer होगा, और जिसका refractive index ज़्यादा होगा, that's a denser medium. When light enters obliquely from rarer to denser medium, it bends towards a normal. So you can see जब rarer से denser में आ रही है, it is bending towards a normal, and when it is going from denser to rarer medium, it bends away from the normal. You can observe this in case of the glass slab experiment also. So today we are going to do till here only. I hope the topics have been understood. If you will watch this video twice or thrice, then it will give you a little bit more clarification, because light chapter is quite a complicated one. So in order to understand it, some students need 2 3 times revision for a particular thing. So I will just come up with the next video in which we are going to explain or some more concepts related to the chapter. So stay home, stay safe, and help your family. Thank you and have a nice day. Goodbye.